Hi everyone, Michael Lysaght. I'm from Citi and I lead our threat-informed defense engineering team.
Hi, I'm Sonali Mendis, one of CCC's working group lead and a senior consultant at Scotlogic.
So Sonali, one observation that I've made that I think will resonate with most folks in the audience here today is how fragmented the industry's approach to cloud security still is. I mean, speaking from my own experience, my own team's experience at Citi, every time we work with a new cloud service provider, it feels as though we're recreating the same set of artifacts fundamentally across each of those cloud service providers. So we're thinking of the big three here, AWS, GCP, Azure. And when we think about the threats, controls, and mappings to frameworks that we do across those three major CSPs and somewhat more broadly, we do feel as though we're replicating a lot of the artifacts again and duplicating a lot of effort. So, and when we look more closely at the threats and controls, it also feels as though at some level, there is a real similarity across the threats and controls and that they're expressed just in slightly different ways across each of the CSPs. And so I was certainly very excited to hear that this is one of the fundamental challenges that the Common Cloud Controls project is aiming to help with, Sonali.
You are definitely not alone in this, Michael. That challenge is exactly what drove the creation of FINOS Common Cloud Controls project. It's an open source initiative to define unified control framework which spans across multiple cloud service providers to cater the needs of financial sector institutions. Michael, I think you will love to see what we have done with the CCC's front-end website. It's designed to make the framework's core building blocks more intuitive and accessible. Let's take a real-world example. Before that, I should mention that CCC starts with a common language for cloud services. Let's take a real-world example. AWS S3, Azure Blob Storage, and Google Cloud Storage. They all provide the same storage capabilities, and CCC recognizes this and provide a vendor-neutral cloud service with the name Object Storage.
Okay, so if I understand correctly then, Sonali, what CCC is doing then is it's looking at a set of capabilities across each of the CSP services. The examples you gave are object storage, blob storage, and cloud storage, and looking at a shared commonality of capabilities across each of those CSP services, and through that defining fundamentally CSP agnostic service based on those shared set of capabilities. So certainly that's the first time I've heard of that approach taken so far within the industry, and it certainly excites me, and I can see the potential for portability for one when it comes to controls, and I take it that's one of the key objectives of CCC then, right?
I'm glad your thinking aligns perfectly with CCC's vision, Michael. Let's explore the main key elements in CCC a bit more. Capabilities or features in this context refer to the minimum set of functionality that should exist for a service to be recognized as an object storage. We have defined 35 different capabilities under object storage. Together, they form what is an object storage. Let's navigate into one of those. Here, you can see a capability that we have done for object storage. Under each capability, there's a unique ID, title, and a description explaining the capability. In this case, versioning refers to the ability to maintain multiple copies or versions of the same object resource. In this example, this is about earlier I mentioned that CCC is all about common language, and this is it. If you take AWS S3, Azure Blob Storage, Google Cloud Storage, they all provide the same versioning capability. They might refer to it in different names, but what they provide is the same exact functionality. And that is what CCC has recognized and defined in a cloud-neutral way.
So really nice. So if I look a little bit further down, I can see threats. So I'm taking it then that one of the ways that CCC incorporates a security aspect into the project is through, I guess, some form of threat modeling against those services, those CSP services, and more specifically, I guess, against the set of capabilities that define that service. Is that the way it works?
Exactly. Each capability is then mapped to a catalog of threads. Let's go into the related thread. Each thread has a unique ID, short title, a concise narrative explaining the risk or abuse scenario, some related features, and when applicable, associated MITRE attack techniques for context. In this example, this defined thread is about loss of data or data corruption, which might occur due to accidental deletion, misconfiguration, or malicious activities. Again, you can see that these threats are defined deliberately in a cloud-agnostic manner to help teams reason the attacker techniques and misconfigurations in a consistent way.
Got it. And I take it then with controls in the name of the project, then the next step that CCC takes as a project is to fundamentally define a set of controls that mitigate against those threats then, right?
Exactly. Let's navigate into one of the controls. Controls is where the mitigation happens. Each control has a unique ID, title, clear objective, and some related threads and control mappings. And most importantly, one or more explicit testing requirements, each having its own ID, text, and applicable tier. This control is about enabling versioning in object storage, and this control may have guidance to enable versioning in AWS S3, Azure Blob Storage, and Google Cloud Storage, all under this same exact control definition. Crucially, each control is then mapped to a threat it mitigates, and therefore to a capability it supports, creating a clear linkage between functionality, threats, and controls.
Okay, you're definitely winning me over so far with the project. So we've got capabilities, we've got threats, we've got controls. So a lot certainly seems to come out of the box with CCC. That being said, one, I guess frustration or one challenge that I have to contend with is control mappings, right? So we all know that tends to be quite an arduous task for sure, and I'm wondering whether CCC can offer any help in that regard, or is it just merely another framework that I would have to adhere to and not offer any reduction in complexity in that regard?
That's a fair question. CCC is not intended to be yet another framework on the pile. It's designed to consolidate and streamline what teams are already doing. Instead of creating a separate threat and control catalog, each for AWS, Azure, and GCP, what CCC gives you is a common definition of capabilities that is built, common language that is built against cloud-native capabilities. These capabilities are then backed by standardized threat models and control sets that are already being mapped to widely adopted frameworks such as MITRE ATT&CK catalog and NIST 853.
Really nice. So the mappings are there as well. They seem to come out of the box. But again, if I'm thinking about where I certainly spend a lot of time and my team expend a lot of effort, it would be focused on controls validation fundamentally, right? So validating that the controls are implemented as expected and that we're validating the efficacy of those controls across environments as well. So a huge amount of time is definitely spent on that. Is that something that CCC is thinking about as well? I saw testing requirements mentioned earlier on. Can you elaborate a little bit more on that?
That's a great question. CCC doesn't stop at defining the controls at the policy level. As you can see, each control in the framework has explicit testing requirements, as you can clearly see structured on the site.
Okay, so certainly looking at these ones here that you give as an example, one thing that definitely strikes me and something that I'm pretty excited to see is the assertable manner that these threats are written in. And certainly it looks like the ones, at least that you've selected here, reflect some behavioral testing of some sort as well, which is really great to see as well. I would imagine that that's not doable or applicable across every single type of control, and that you'd need to also do some sort of configuration scanning for certain control types that are not testable in the way that you have the assertions written here. What is CCC doing to help implement these tests, or is it just focused on writing the testing requirements? Are you working with any other frameworks in terms of the actual implementation of the tests?
Spot on, Michael. That's where CFI and Prowler comes in. CFI, or Compliance Financial Infrastructure, is aiming or focused on building secure infrastructure as code based on controls that is provided by CCC. You can see one of the secure S3 bucket Terraform module that CFI has produced in this page. To extend this further, we are now collaborating with another open source project that is named Prowler to integrate the CCC control definitions into their existing runtime scanning engine. So what you can see in near future is that you can validate CCC defined requirements using your existing Prowler scans in your own CI/CD pipelines.
Really nice. So definitely, again, you continue to win me over with respect to what CCC is offering. There's no doubt about it. Really exciting project. I mean, one last thing that comes to mind is that if I'm to, seriously think about adopting CCC, I'd want to know that it's backed by some pretty serious players. Can you tell us any more about who's behind the project, Sonali?
That's a great question, Michael, and one we take seriously. CCC is hosted and open sourced under FinTech Open Source Foundation, or FINOS, and it's actively driven and governed by major global financial institutions, leading cloud service providers, and cybersecurity experts across the industry. The support that we receive from both FSI community and CSPs has given a strong foundation to the project, not just technical, in terms of long-term sustainability and alignment to industry needs.
Really nice. And one thing that I want to underline on top of what Sonali has just said is that CCC is not alone in the FINOS ecosystem today. You might have heard in today's opening session the close collaboration between the AI governance framework and CCC, and that collaboration is going to get even stronger in nature in the near term, which is a really exciting moment for us, for sure. So that integration or collaboration as it happens today, and it's been in place for some time, is one whereby CCC consumes the output from the AI governance framework. It enhances the controls and threats that are emerging out of the AI governance framework as it incorporates it into the CCC threats and controls catalog. And you'll have heard that CFI is now a core component of CCC, and that's where we're focused on implementing not only the hardened Terraform to adhere to the standard, but also on top of that, the validators to test our testing requirements and the control efficacy that we mentioned earlier. So CCC as a project, it started back in 2023, but it has been energized a lot over the last year, to the extent that we have successfully released 3 services so far. So that's RDMS, VPC, and object storage that Sonali presented a few examples of. We've naturally got a lot more in the pipeline. We're getting a lot of positive feedback from the community, and there's various different mechanisms that we're using to get that feedback. One being the change approval board that we have in place every time we release a new service, which is reflective of quite a broad community. But truth be said, or truth be told, that we still have quite a journey in front of us, as you can imagine, right? We've only just started on the services, and there's a huge amount out there, as we all know. So there's quite a mountain to climb in terms of coverage. We do have a couple more release candidates in the pipeline that we're excited about and that we're going to get over the line in the next few weeks, hopefully. But we do need more contributors, and this is a call to action more than anything else. So again, we feel that CCC can offer real value to the community at large, but it will only do so if we get more contributors on board. And yeah, there are many different ways that you can contribute that we'll talk about in a moment or two, but it would be great to have more people involved in the project, naturally.
To add into what Michael just mentioned, we did our very first release in January 2025. We released object storage and VPC. And not very long ago, May 2025, we did our second release, which included RDMS. And you can see our pipeline. We are working on refining capabilities, threats, and controls, and their mappings and test requirements. All of this for load balancer, crypto key management system, and virtual machines, and identity and access management. What I'm trying to say is that we need your help. There's a lot more to do. And most importantly, we are ready to receive your help. We have done 2 releases and we have laid the groundwork. So we are now in a better position to get your help to shape the future of cloud security together.
Great, and here are the many different ways in which you can contribute. So lots of different angles, lots of shallow paths into the project as well. So from documenting control catalogs to the opportunity to get involved in threat modeling against the services, the capabilities more specifically. And we definitely need quite a lot of help on the mappings to other frameworks. And then there's some really interesting opportunity to get involved in defining the test requirements, but not only defining, but going and implementing the tests now that CFI is a core component of the project as well. So an exciting moment in that regard. As Sonali mentioned, the core foundational structures are now really firmly in place within the project. So really a great moment to get stuck in and deliver value at speed within the project as things stand today.
If you think this is a worthy cause, I invite you to take a picture of our QR code, which will lead you to the CCC's front-end website, and from there to our code base and to our community calendar. So that's it from us today. If you have any questions or feedback, or if you are interested to learn more about the project, please find us, please talk to us. So we will be more than happy to walk you through in more details about our project. Thank you very much.
Thanks.
We do index that. So I work at AWS, I'm the exec sponsor for this, and we do index this into our coding assistance, so the test harnesses and all that stuff as the library was built out, and naturally we included controlled engineering and all that stuff. So we like this project. We wish more people were engaged.
Yeah, I think we're starting to gain some momentum for sure, and we're seeing some, a little bit of mass there within the project now as well. So again, to everybody, a really exciting moment for more contributors.
If we can get critical mass, we can build product around it too. There's nothing that would prevent me from going to the control tower team and saying, okay, here's the controls library that we need to support from the.
Yeah, super.
we are working towards it. And to build the critical mass, we need more contributions. And that's this presentation is about, to invite you all to contribute.
Go help.
All right, you don't need to work hard to find us. We'll be at the CCC booth. So thanks again for listening and look forward to hopefully speaking to you later.
Thank you.
Take care.
Thank you.